Just a quick little review here. We talked about direct variation yesterday. Did I give you this? Y equals k times x. Did we do that?
No.
Okay, well, let me just throw that at you here, because k is what's called the constant of variation. It would be also what's called that constant of proportionality. Remember when yesterday we did the old, who had a job? Jake had a job for what? How much an hour? $5 an hour. He worked 0 hours, he makes $0. 1 hour, he made 5. 2, he got 10. Most Jake's ever worked in his life was 3 hours in a row, and that got you to 15. So, what do I do every time 2x to get my y? I multiply by 5, right? So in this case here, the little formula I have, y equals 5 times x, correct? Y equals 5 times x. K was my constant of proportionality. You know, the beauty of that is, all I need to do is, know how many hours Jake works. Let's say he worked 10 hours. I know I'm just going to multiply that by my constant of proportionality, or my constant, whatever it is there, times 10 times 5. I know Jake's going to make $50, right? So if you can find out what this is, it's going to make your life a lot easier, because then you don't have to make tables and figure all this stuff up. You just know you multiply this by that constant and you get that. That's what we're talking about today. Let me write you a problem right out of the book here. Write this down. Ellen charges $780 for 60 people. Ellen charges $780 for 60 people. How much would she charge for 100? How much for 100 people? Okay. By the way, there's a bunch of different ways to do this problem, so if in your head you're thinking, well, this is what I would do, and it's not what I'm doing here, that's okay, but I want you to think this way just for a little bit. Let's just think if we were making this a table, of x and y table. And you don't have to do this for everyone, but let's try to get you to think this way. I want you to think about this. Okay? Which one, the $70 or the $60, would you think would be the x value? Now the x value is the one that changes. I mean, they both change, but the x value is the one that we call it is your input number, the one that you say, okay, what's going to change? What changed here? The people or the dollars? The people, and that's the one I know. I know that for 60 people, it was $780. Okay, I want to know for 100 people how much that would be. Okay, and yes, you could actually do this, I believe, fractional way, but we're going to talk about it. We want to find out what is our constant of proportionality. In other words, how do I find out what I multiply 60 by to get 780? Anybody? It's a division problem. You want to know what times this gives you this, so you take 780 divided by 60, and that equals what? 78 divided by 6 is 13. So what is 13? If I serve just one person, how much would it cost me? $13. If I do 100 people, how much will it cost me? 13 times 100, which is 1,300. Okay, so that's kind of how you have to think about it. It's a little like unit, pricing or whatever, where you want to know how much. It was $780 for 60 people. You want to know how much would it be for one person. So you just divide the bottom into the top. Same sort of thing, but they want you to think about it as direct variation, which is kind of what we're talking about. How about another one?
What if the number doesn't
They'll work out pretty much. I think the book will make them work out. You could work with decimals, but for fractions, it would still work. Christine?
So is it kind of like a ratio bar?
It is, but they call it, I mean, most of math has like it's 8 different names and you just kind of have to figure out, yeah. You can do it ratio box wise. How about this one? There were 23 people in line waiting to be helped. We'll see if this works. There were 23 people in line waiting to be helped. 3 minutes later, there were 18 people in line. 3 minutes later, there were, how many people did I say? 18 people in line. How much longer before, oh, I suppose I was supposed to tell you that somebody was in line. Well, 18 people in line, how much longer before you're helped? You're at the end of the line. You're at the end of the line. I'm at the end of the line. 18 people in line. How much longer would you have to wait? So you're behind all these 23 people. 3 minutes later, there's only 18 people in line. How much longer will you have to wait? Any thoughts on how we can go about that? Ev? 18 people divided by 23 people, I don't think will get you there. You need to find, and I know you know that because of the only 2 numbers in there, but that's not the numbers you're actually looking for. You might have to do a little math before that there. Jacob?
Well, you know that every 3 minutes, 5 people get served, so.
Okay, so if we looked at this, and here's where it gets a little, well, I guess maybe this is the question you had right there. Every 3 minutes, how many people were served? 5 people were served. So what's changing is, you want to know the change in minutes for the serving there. There is where it comes when somebody said, what if it doesn't work out evenly? Alright, so what's happening here? How long does it take for one person to get helped? What did we do the last time?
Right.
Divide it. It's not going to work out nicely here, but what is one? How long does it take one person to be helped? If you divide this out, you get what fraction? Well, just leave the fraction proper. Sometimes it's best to leave it proper fractions. What's 5 divided by 3? One person, you get one person is helped every 5/3 of a minute, right? Is that right? Okay. So how many more people have to be helped? So my proportion, so y equals 5/3 times the number of people. How many people are in front of me? So where do I put that? Right there. What is 5/3 times 18? For cross canceling, I end up with. So how long will it take me to go 18 people? What's 5 times 6? It'll take 30 minutes. That was kind of a tougher one. If you don't get that, I completely concur and understand that, but it's just kind of the way it has to be. Look at page 473. And again, yes, Christine, you probably could do that same thing proportionately, or ratio box wise. Look at letter B on page 473. Let's see if we can't hammer that out and do one more here. The number of words Tom types varies directly with the amount of time he spends typing. Okay, think about that. Which one would you make X, which one would you make Y? What are we talking about? We're talking about time, and we're talking about words typed, right? which one of those do you think is the input or the X number? Right, because you always wanna know how many, how many minute words you type per every minute though. So X is time, Y is words. What do we know? How fast what does he do?
20 words and
In 2.5 minutes, he does 100 words. Okay, and we want to know what? How many he types in 15 minutes. So if I asked you what our constant of variation is, or our constant of proportionality, or whatever it is, how would you find that out? What do we do every other time? Yeah, what is 100 divided by 2.5? It's 25 into 1,000, which is 40. So you know to go from X to Y, every time you have to multiply by 40. And 15 times 40 is? 15 times 40 is 600. If you only type for 1 minute, you type how many words? Somebody? 40. It's an interesting way to think about things. As you might say, perfect. All right. I think I have a quiz for you.